Okay, so with that I begin. Okay, so in the basically the goal of the project is basically to address the SDG, the UN SDG goals, any one of them. So Priscilla, did you go through the SDG goals, development goals?
So which was shared before, right? Yeah, yeah. I just went through one, so.
Okay, at least you should have some idea. Let me just I don't know where the documents are. Okay, but the is it over here? Okay, here there is a little bit of description in one of the documents which Sashank has sent, and let me expand.
Yeah, this document was published in December, like 2 months before, by this organization only.
Okay, great, great. This is all the documents are really good. So whenever we hear the term sustainability, always remember something to survive. Okay, so in order to survive, we need a good environment, and we need proper food, we need proper infrastructure. So sustainability comes into sustainability covers everything that a human needs, right? The normal environment and the sustainable. So basically, our world is a world of inequality, and there is a very big portion, 80% of the major, more than 80% of the portion people still not having many things. Even half of the world do not have internet, and so this is where the UN basically they came up with some goals that this is what we want to achieve, and they are giving these goals to every country, and every country tries to measure itself against the goal and how much they progressed, and that to prove that we have done this and that. In this project we are focused on using the fire. I'm going to call it a fire, actually it's 5 IRE. So how do you use this technology which is connected with blockchain to solve any of these problems? So definitely the problems, which global problems, as I told you, so today is mentioned about the problems over here anyway. So here I can see some highlights. So now the poverty, the goal number one is that there should be no poverty. The goal number two, so when you say poverty means money, another thing is the money involved, and zero hunger means no hunger, good health and well-being. The third goal, quality education for everyone, gender equality. So still, women have not, in numbers, or equal opportunities. There's a lot of inequality still at least with between men and women in the industry, and this is where and partly it may be because of I do not know what reasons, but different parts of the world, there may be some inequality for whatever reason. But in every country, even if it is developed country, there's a certain level of gender equality. Even in salaries, they have always found a difference in terms of how much a woman gets versus how much a man gets. And so those are the little, that is one area. Water and sanitation for all, affordable and clean energy. So we are, our environment is getting polluted and everything, with bad energy. So when we say clean energy, means energy coming from the sun, energy coming from the water, energy coming from the wind. Those are called clean energies. But these energies, if you go to buy a solar panel, it's going to be very expensive, so it is not affordable. So we have the technology now. If you go to electric energy, using electricity, but the electricity has to be generated how? By the clean energy. So right now we are using mechanisms, where there's a lot of carbon dioxide emissions, and that's why clean energy is required. And so petrol and all these kind of fuels are it's supposed to go away, and it is supposed to be replaced by electric vehicles, even when then eventually by solar technology. So decent work and economic growth. So if you like look into each one of this, it will be some problem which is kind of at a very large scale in the world. You'll have to look at the statistics for each one of them to see how it is destroying the world, how it is causing the problem. So we are trying to come up with at least one little thing that we can do to contribute towards these goals. So that is what the SDG goals are, sustainability development goals. So you are kind of now helping the UN, or helping your country to come up with these solutions through this hackathon, and also you are helping this technology provider, Fire, and by that they're trying to promote their technology in a way through this, and also be aligned with the sustainability goal. So if you have a product on their technology and the technology is accepted by the UN, then their technology also wins. There will be more people accepting the technology. So it's a kind of a win-win situation in that case. So that is all about SDG goals, and so initially I told you, we have to choose one area in terms of which problem you have to solve. So whenever we are so basically we this is a tech solution which we are providing, and then how do we go about giving solution to any problem using technology in the world. So how do you use tech? So as a designer or as an architect, you have to understand everything in the tech world revolves around three things. One is data, one is the process, and one is the user interface. So as a any application that you develop in the world, that will have some data, like a mobile app will have some data. It will have some process defined, like in the sense Ola car is we want to book Ola car, that is a process. So how do you do? Somebody goes through the user interface, then something happens in the background process. Some processes may be running in the user interface also, but we are mostly talking about the background processes which is running in the back end. Like somebody takes a request of login, and then you are allowed to log in. Somebody takes in a request of booking, and then you get a booking, but the process by itself does not does not with the help of data. So user interface may be there, may not be there, but there will always be process and data. So the whole software world, or the whole technology world, is revolving around data, process, and user interface. Is this part clear, Sashank, for you?
Yes, sir.
Okay, so so this is how you should design. You should always say, okay, I'm solving this problem. What is the data associated with it? What is the process required? So in process, whenever you're thinking about the process, then definitely it is got nothing. It has got more to do with the domain knowledge. So in the sense, if you're solving the health problem, then you have to understand the health domain. If you're solving the poverty problem, then you have to maybe understand the income problem. If you are looking at any COVID problem, then you have to understand the problem statement and the domain around it. We're not talking about the tech part, we are talking about the domain part. And even here in the data part, we are concerned with the domain more, so in the sense, what data should is required to identify a COVID patient. So you can say, oh, I require the coordinates of the patient, I require how many vaccinations he has taken. And so basically it is like pretty much, if you start thinking on your own, you will come up with your own logical conclusion. This is the data required for deducing whether somebody having a COVID or not. And user interface is definitely more of a technical piece, you can say, give which you there's some things which will drive through the user interface, and some some set of users may come through the user interface. If it is a problem statement of solving the poverty, so then how do you solve the poverty problem? Maybe through the user interface, somebody comes in and does a biometric verification, and the biometric verification that is done on the by the process, and that process goes back and looks at the data, is it been verified before or not. So these are all connected things, but these are user interface. We are talking more about the technical. Once you your domain part is very clear as to what data and processes are there, So basically in process, when you say then for the technicality purpose, we have to deduce what are the functions of the process. So let's say what are the functions of the process, and this usually the functions of the process will be in order. So there may be one or more processes, and in every process there may be one or more functions. So for example, a process to identify a COVID patient. First, get in his Aadhaar card number. Step 2, second function, verify the database if he's been registered. Step 3, verify how many vaccinations he's done. Step 4, it will go on. So everything is a function. So every time there is a function, the computer technology basically makes sure that it gets hold of the data wherever the data is on whatever service line, and do a verification. So those are called the functions of the process. Once you know from the domain perspective, this is a process, this is the functions, that will most probably become your function calls inside your program. This is how you come to know, or you design any system. So in order to know what function calls inside the program, so I will have a function, as I said, get Aadhaar card, and then the other function will be uh, get total vaccinations done. So these are basically, I'm not even getting into technology, I'm just talking about the vague logical, your domain area. How do you think about solving any problem in the world, or being part of any hackathon? If you're solving any problem, how you should begin thinking, and so forth, right? Get location of the user, because we have to know where he is, and then is user in vicinity of other patients. So you say a normal, without even looking at the problem statement, with a little bit of idea about COVID and everything, I was able to understand what could be the process, what could be the functions, and what could be the function calls inside the program. So ultimately, this where do you get Aadhaar card from? Maybe this Aadhaar card is going back to your government. There is a box over here, and probably that box is containing all the other information, and from there basically you're getting the data. So definitely where there is data, there is database. So database, in technology world, database can be stored in SQL format and NoSQL format. So study bit a little bit on this. So basically SQL are basically something, they run through mostly using your softwares, and you cannot directly read them, and you need to design, you need to mention what are the data that you need to store, and even before using it. So but in NoSQL, it is just in a simple file format. So all the data is basically stored in one file, and in this the data from that one file, the data will be in either XML format. Mostly we use JSON format, and sometimes we use YAML format. We rarely use XML format. Mostly we use JSON format, but sometimes there is a we use in a YAML format also. But ultimately these files are nothing but a file, just like any other file. It is the data is stored in that particular file. You read the file and you look out for your data over there. So when you are trying to search for a particular text in a NoSQL file, it is little bit difficult to logically find out if there is a particular piece of information, compared to SQL. SQL is working in very close tandem with your machine. On this machine, basically generally the machine has a hard disk over here, right? And this hard disk will have addresses, right? At this address this data is there. Then it is just like a CD. So CD, every spot is a data, basically your music data or your video data. Every point on this hard disk is basically address. And basically SQL, basically how it works fast mostly is because of indexing. So in indexing, if you want to know, indexing is basically a kind of a database of address and data. So basically saying, if I want to search for Shashank's Aadhaar card, at what address is it on the machine? So the SQL technology is little bit complex when you compare with NoSQL. So you have to go through the index, you have to go through the machine, and then the fast is the the data is fetched faster. But in NoSQL, all that you do is you open the file in your notepad, and you what you do is you are seeing data over here. So your Shashank's information maybe something like this, within open braces and everything, and the name is colon Shashank. Then maybe other card information is something something something. So this file has got nothing to do with machines, and this file can be stored anywhere, can be transferred anywhere, can be sent over the internet. It has got less complexity. Now why NoSQL is beneficial? Because there is a lot of data flowing all over the world. In each day there's so many people on the social channels coming over, uploading the videos, seeing the things. There's a lot of uploads and downloads happening, and the speed of the network is becoming less for us. For at least for the ones who have the internet access, who have access to all this, the amount of data flowing is more, and that's why the big data is an area of basically handling such huge amounts of data. But big data problems are usually solved using NoSQL. So at times we want to use SQL, and at times we want to use NoSQL. But the idea is, this process or this functionality is going back to some database, to some server. So this server may be belonging to a government, and this government server IP address may be 10.12.2.1. So any, if you want to get to any machine, you have to basically know the IP address. Okay, so using IP addresses only, all these devices are communicating with each other. So it is quite possible that all this functionality is implemented on your box. You have all the data with you also. At the same time, you have everything. So you don't really need the IP address. Just is mentioned, I want it from a local box over here. So but it is not necessary that one process is connecting to only to one server. It can be connecting to many servers. So in an ideal organization, we have many types of servers. We have servers where files are uploaded and downloaded, so we call that as a file server. So anytime somebody is uploading a file like a Google Drive and everything, all that is going to some file server. Anytime you want to send an email or want to receive an email, it travels. First you need to contact the email server. So if you want to send an email to Google, then you have to connect to mail.google.com, which is a email server for Google, and that Google server will know, okay, this is the person, the email has been sent, and the email has been sent to so and so address. So every server, every application, every type of server, it uses certain protocols. So a file server would use FTP protocol, emails would use SMTP protocol. Means is a way of communication. In SMTP you will have from address to address, but in FTP protocol you will have the file name for file size. So the different types of protocols are catering to different kinds of service. Okay, so then we have application server. Application server is basically if we have a particular website which is a website application. If there are 10,000 users, then we want to have multiple instances of the application server to manage the load. So how will we do that? So application servers helps you manage manage the application. So your TCP IP may be used, and your normal your HTTP may be used. It depends on how the application has been written. So any questions on this so far? Any doubts?
No, sir.
Okay.
No, sir.
Okay. No problem. No. So whatever terms you don't understand, the SQL, NoSQL, all these terms are very important. So what is a file server, what is email server, what is application server, all these terms are important. So make sure you are aware about it, so that anytime anybody in the world asks you, or any interview they ask you, at least you have some idea. Okay, having said that, let me see what is it. So once you understand that everything works in the form of data process and user interface, so client server architecture understanding becomes very difficult. So in the client server architecture, your client is usually we are talking about the user interface. So in and there is a your process and your data is managed on the server over here. So here is where your process is running, and here is where your database is existing. So the process is accessing the database to collect any data. So in any client server architecture, there is a client which is mostly a user interface, and it is connecting to your server, and the server connects to your process, and the process connects to your database, and all the data is coming back to the client. And that's how your, let's say, your client application show the data. Now this client, usually when we talk in the website, in your internet world, this is your browser, and this is your web server. In the so as I told you, there's file server, there is a SMTP, there's a email server, there is a application server, so there is also a web server. Web server is used to host websites, right? So in client server architecture, the clients usually, they don't have the logic, so they don't know, like your browser doesn't know how to book a Ola. So all the browser knows is, if I want to book to Ola, I need to connect to server with where the name of the website is ola.com maybe. So I need to know where ola.com and which server it is, and connect to that server using its IP address, and start communicating it using the HTTP protocol or whatever protocol the server is allowing. If it is a website, then definitely HTTP protocol will be used, right? And then you begin the process. So server then basically gives you all the data in the form of HTML, in the form of CSS, in the form of JavaScript. All that information may be coming from the client side, or there may be some front-end programs. So front-end programs you can have written in HTML, CSS, and Java, JS or JavaScript. And in the front end, you can also use Angular JS. And then you have
React,
sorry,
React. We can also use React.js or
React
Vue.js.
JS. Very good. Yeah, so React JS works in tandem with the Node.js, and Node.js is mostly it runs on the server. So usually, so you have to install Node.js over here, and React.js has to be installed on top over here. So it works in tandem. So mostly React.js, you can say, it is a kind of a bridge between the front end and the back end. Whatever happens in the front end, like somebody is clicking the button on the front, the back end process is. So we definitely want to know now, when the mobile, somebody is, let's say, browsing some part of the, somebody is viewing something, then we want to back see what is happening. We want to track it basically. Let's say how many users are watching something, then React.js can come to use without even informing the browser. He will not come to know also. But the thing is, yeah, you are right. React.js is a kind of but it is a more of an kind of a framework which is moving between backend and front end. In the backend, it works with Node.js. So Node.js is a more of a backend application. You can create a web server using, or a website using Node.js also. So and in the database, definitely, if you're going with NoSQL, then you have MongoDB over here. If you're going with SQL Server, then you have Microsoft SQL Server, or you have Oracle Server, and so you have Cassandra as your NoSQL. So there are different types. There are around 4 types of NoSQL also. So depending on each type of NoSQL will be having certain quality. So you can have if you want to study databases, then probably you will have to you study across all this. What are the different types? What is partition? What is sharding? So basically, because it is a file, you can split one file into two. You can split columns also. So those are called partitions and sharding. So that is a database concept, and just want to give you a little bit idea that we can play around with files more easily than we can play around with SQL. But in SQL also these days it is more advanced, and you can support partitions and MongoDB. Sorry, partitions and shards. So partitions is like you are you have a 100 MB database, then you're taking 50 MB and putting it somewhere else, and then you're taking another 50 MB and putting it somewhere else. But in both of them there will be 3 pieces of data, which will be name and Aadhaar card and state maybe. So in both the places that will be there. But sometimes you can partition based on columns also. Like you can store name in one area, one place, on one box or one part of the hard disk, and you can store your Aadhaar card information in another part of the system, and both of them can be logically connected as a singular database, a small, same database. So when you're accessing, you will not realize it, but they are partitioned. So definitely the advantage of partitioning is your load is distributed and you can split across the database. When your database size increases, you can break down your database into partitions and shards, and give you and implement some parallel computing on this to make a parallel search. All this magic can happen once you split the data across many servers, and then you give it like a task using techniques like Hadoop techniques, or map reduce techniques used in Hadoop, and you can fetch the data faster. I mean, that's how Facebook is managing millions of data, right? It cannot be all on one server. All the data is spread across. So that is your client server architecture. So anytime somebody tells you about a client server architecture, we are there is a server, there is a client. In the one is an example of browser. Another example will be your mobile application, right? Your mobile app is like your client. Their client, but mobile app does only has the programs that is used to run your front end, like show a certain color on the screen, or see what user has clicked. Those are the things you can implement in front end. Any processes that have to be implemented has to be implemented on the back end. Now it is quite possible in the mobile app. I'm not sure if the server part of the component can be installed in mobile app, but in a single computer we can implement both client and server. So you can have a browser running on your same box in a laptop, as well as you can have your same Node.js server running on the same box. So in the mobile app, when you want to write a mobile app, then definitely you have to write the using tools like Kotlin or something. And what else is there? Mm, any app, any languages that you use to write
React,
sorry,
React Native,
React Native, maybe,
Flutter.
Flutter. Yeah, I have heard about Flutter. Very good. So this so whenever you're using this front end tools, definitely then are you the main two competitors are definitely your Android and your iOS, right? iOS is your iPhone. No, sorry, is iOS iPhone?
Yes, sir. Yes, sir. Swift.
And, and this the Android is Google. So these are the two main competitors. We have not seen any other major players. So India is basically want to get into this space, but this has been a very difficult challenge, and we want to be Atmanirbhar, we say, but we don't have our own operating system. And but that is one of the opportunities in India we have, to build our own phone, build our own operating system. But in from this right now, from the conceptual perspective, what I want to focus on is a client server. So we can be a mobile app, it can be browser. Any other front end you can think about? So you can have a virtual reality glass, right? You can put on so this is a new thing, no? In the metaverse, metaverse is basically your websites which is viewed using your virtual reality glasses. So using the virtual reality glass, your computer has shifted from your browser. It comes to mobile app. It has come to your glass, and definitely these days we have watches, no? So watches can communicate with your servers also, and so we have all uh, uh, which can which may have a front end, which may not have a front end. We do not know. For example, LED display or something, we do not know. But LED display, IoT is basically more of a hardware, robotics, front end, like sense, your image sensors or something, etc, etc, etc. So there is a lot of front ends these days. Everything is connected in a single home. There are all smart devices like your smart TV or washing machine has a smart intelligent way of knowing whether or how much water is there, and everything is connected. Whether the fridge knows how much, whether there's a bread in your fridge or not, and it will send an SMS to you. So the IoT world is full of these data points, and that data point, all these data points can be collected by an IoT server. So your IoT server then ultimately can contact, send the data all to a web server, and the web server can display it on a website. With the website will be displayed using a browser or a mobile app. So all these systems can be connected that way. So I hope this was useful. So I hope next time you are not confused with client server. So the question comes with so any application in the world will be using this architecture in some way. There's a client and there's a server. Sometimes it is quite possible that so there is a client on one side and it trying to look out for data on the server. But it is quite possible, as I told you, the functionality get Aadhaar card may not be implemented, or may this server may not know how to get the Aadhaar card. So this server then becomes a client to another server. So this can be a government server, server number 2, and in which case the server number 1 becomes a client to server number 2, and client number 1 becomes a client to server number 1. So understand this concept. So server does not mean always it is serving. Sometimes it is also serving, at the same time it is also a client. But the important thing is any machine can connect to any other machine in the world or any other device in the world in a digital world, provided it has a IP address. And networks comes into place over here. We're using your network, we find out where the IP address is and we connect to the machine. We start talking in the language or the protocol that it supports. If it is a website, we start talking in terms of HTTP. If it is a file upload or download, we start talking in terms of FTP protocol or SMTP protocol if we are sending and receiving emails, and so on and so forth. So here what I wanted to talk about is a three-tier architecture. So how is a three-tier architecture different? So three-tier architecture is like your three components of the system. So what I told you, the components of the system is one is your user interface. So one is a user interface. So this is your first tier. Second tier is your process, right? Is basically your business logic will be running over here, all your business functionality. And third is your data component, which will be in the form of all your database will be stored over here. So this three tier, it is usually it is better that it is on the separate machine. User interface is on a separate machine, process is running on a separate machine, and database is on a separate machine. Now in case the load is increasing on the process, like that too many users accessing the browser, because there's too many browsers all across the world. For example, there are too many Facebook users, so their database will be stored in different place. And again, if the database is too big, then that will be split across many servers. If the process is too big, then application server will be used to manage the load. So load balancing technique or something will be used to manage the number of users hitting the server, the process server. So in a three-tier architecture, so usually we have a browser, your user interface, your business logic, and your database logic. But ideally these three can be implemented on one machine, but it can be, but in which case it is a logical tier then. So it's a logical tier, we can say logical tier number 1 or logical tier number 2 and logical tier number 3. So that's why it's called the 3 tiers. So initially when we started building application, we went with client server, but later we faced this problem of if the process and data was running in the client server, there was only it was a 2-tier architecture. The earlier example was an example of a 2-tier architecture, which is a client server architecture. So in this we are dividing this 2-tier into, we are converting this 2-tier into 3-tier. And what happened in 2-tier, basically if the backend server is loaded with, is managing the data also, is managing the processes also, the load is becoming too much and it will crash. And once it crashes, your website will stop functioning, or your front end cannot no longer interact, and then again you need people to make sure it starts. So that's why they came up with this technique where a 3-tier, if one database is so always they will have a backup database also, and they will have a switch somewhere in the architecture. So the switch will basically make sure that if the primary database is dysfunctional for any reason, so the process will always connect to this switch over here, and this switch will either connect to backup database or database over here, or it may connect to any of the database. Maybe both of them are active database or active passive database. So basically it is we are trying to solve the database problem separately. We are trying to solve the process problem separately, and we are keeping the user interface separate so that we can focus and it is easier to manage. So that is a 3-tier architecture. So whatever terms you are not understanding, make sure you read up more on this. So what happens in a 2-tier and a 3-tier, there is always a, there is one server. Whether you take a 2-tier or whether you take a 3-tier, there is always a centralized server. Whether you take a 2-tier or a 3-tier solution, there is one central server, right? This is where, and there is all the clients, all the browsers in the world, all the mobile apps in the world, they are going through this server over here for any purpose. So it is like a door, to the backend database, to the backend processes. So this kind of architecture is also called centralized architecture. So let's say now, we want to solve the poverty problem for the world. Now the question is, who's going to manage the server? Who's going to, sponsor the machines? Who's going to sponsor the engineers? Who's going to code and everything? Who's going to maintain so much of data over here? Is it, this is kind of a single authority, some single authority like taking over the entire data. What if the single authority is abusing the data itself? Let's say all our other kind of information is going to the central government, and on the server somebody is leaking the information. Then what do you do? How do we protect ourselves as clients? That is where there was a time when the economy of the world came down in 2008, and that is where the banks started saying, we gave loans and the people don't have money, so we are bankrupt. Now where do they get the loan money from people like us? We invest in FDs, and they take our FDs and they give us little interest, but where they give loan to some other party and take a bigger interest. So I hope you all understand this financial economics, that if we are given a 6% interest, they're taking that money and giving as a loan to somebody else at a interest of 16%, 18%. So whatever the interest, the difference is, that becomes the profit for the bank. That is the business going on. So now what if the banks go down then? That is what the banks did. No, it went bankrupt. A lot of people lost houses. A lot of people lost jobs. And what did the government do? Then the government bailed them out. They said, okay, no problem. We want your company to survive. We want your bank to survive. So take this money from the public. Where the money comes from? Income tax. So we have all given taxes and everything. Okay, now we have to save this bank, and that bank is a private bank. It's not even a government bank. So you can understand. So basically, this blockchain, as this whatever is emerged out, is emerged out of this problem. So, and this problem is basically they want to do away with centralized architecture, where we are dependent on the government, where we are dependent on the processes. For example, if you are using a Visa card or using a MasterCard, okay, here we need a Visa card, there we need a MasterCard, here we need the Aadhaar card, in some other country we need a social security number. As users or as a citizens of this earth, we are constantly facing the whenever something goes wrong, we as a citizens of the world, sometimes we face a problem. So this is the problems which were, because of the financial problem which went down, the Bitcoin was implemented. Is there any doubt on this centralized architecture, or why what is the disadvantage of a centralized architecture? There's always a single authority. All the database, all the processes is there with a single authority or single person or a single company or a single government authority which owns these servers. So you're always dependent on that server or the authority which uses the server. So now when you talk about peer-to-peer architecture, we are talking about we are still implementing client server architecture, but there is duplicate copies of it. So you will have one duplicate copy, where there will be still the server and the web server component will still be there. So there's one server over here and there is a database over here, right? But the thing is, the way Bitcoin is implemented, in the sense the blockchain technology and it using somewhere underlying, it is using peer-to-peer architecture, which is not a centralized architecture. This peer-to-peer architecture, there is a duplicate copy of the same server everywhere. Whoever wants to duplicate this copy can duplicate. So one person cannot have an authority over that particular server or that database. If I want to duplicate if I, for example, I want to implement the Bitcoin, I want to become the server, you can. Nobody can stop you, because that's how Bitcoin has been designed. You can download it, you can install it, and the moment you install it, you are exact same copy. Now whenever there's a changes in database in one end, like somebody, so the thing is, ideally we always start with the one server. So at this point definitely some client will be connecting to this server, and in this case it's still a client server architecture. This machine server is also called a node, and that is what is called a node. A node is a server basically, which is responding to your client, and your client can be connecting to any of the nodes, and that server will be having its processes and database also. But the question is now, how does a peer-to-peer architecture work then? First of all, as I told you, it's a duplicate copy, which means this node is going to be replicated. Let's say Shashank is in Guwahati, he wants to implement a Bitcoin server. He can implement. He can download it and he can implement. But the question is, how does so this is like Shashank's machine now. So the node is definitely going to run on some machine, and that machine is belonging to Shashank, let's say. And on this front, this node initially Priscilla started a new currency, and she called it, she called it, what, um, pen rupee, something like that. Let's say some currency. So or let's say she started Bitcoin itself. So she named the currency Bitcoin, and she started over here. So she was the first person to implement a Bitcoin. She was a creator of the Bitcoin, and she implemented a server and code. So she wrote this program. So in the when you actually see read the history of Bitcoin, this person who created this, we do not know. He has disappeared actually. So it is an amazing mystery, and Bitcoin has grown without him. But you can see what all he has done, what data he created before going, what server program he has written, because it is all open source. So you can read it also, you can see the data also, you can see who has done what with this and everything. So that person name is Matoshi. They just to refer that person, we are given him a name Matoshi. So just read up in case, where is Matoshi, who is Matoshi. There's all discussions about it. And why did Matoshi, when Matoshi created the database, this database was created using a blockchain technology, blockchain architecture, blockchain data architecture. So blockchain is, you can think of it, the technology consists of definitely nodes, but blockchain also refers to the way data is stored. So the data is encrypted, the data is stored as a chain of blocks, instead of chain of records. So that's why the word blockchain comes up over here. And so at this point, when only one server is there, Priscilla has created it, nobody is involved so far. The Shashank server is still not on. Priscilla woke up one day and created a Bitcoin server. It is still operating like a client server. So but what did Priscilla do or Matoshi did when he created this server? He said, no, I want it to operate in a peer-to-peer architecture. So definitely peer-to-peer architecture means somebody has to be able to download this, duplicate this copy. So there has to be some way of finding, downloading the code and everything, and there has to be, so that is called a node, initiating the node or something. And definitely other thing is, if this application is a duplicate copy of this machine, which means the database and the code all has to be the same, which means the code running on server 1 cannot be different from code running on server 2. If here a plus b is equal to 3, here also a plus b should be equal to 3. And if here there is a data a is equal to 1 and b is equal to 2, then here also the data has to be a equal to 1, b is equal to 2. It is like your bank accounts, So whether you are in one branch or another branch, whether that is and you're using a duplicate database, that database cannot be different. This account number showing a balance of $10, and the other balance also has to show your same account with an account of $10. Now depending on which branch you go to, you will be maybe told, okay, this is there's a kiosk front end, touch the screen and see your account information. There's an ATM machine, and that ATM machine is connected to the server on Shashank's box. So the database has to be the same. So if I check that data over here on this node also, then it should be the same. If I go on to some other branch and through some other bank and I check, it should be the same. So ultimately this both are acting like a branch of branches of your bank, but is different data stored in different branches of the bank? No, nowadays whichever you can say I opened an account in Borivali branch, but I can still check my Borivali branch account information in Palghar branch. I can still check it in Kandivali branch. Or I can still go in other part of the country like Guwahati and check my same data. So basically database has become common. So the thing is, but is the database in one place? We don't know how they have implemented, but ideally they would create a duplicate database. That's what would make sense. But in a peer-to-peer architecture, so as I told you there is a server and there's a client. So server, there is one master in the client server architecture, but in a peer-to-peer architecture, every server is a master. So you have more than one master over here. So this is also master server number one, and this is also master server number two. So whenever data is added, somebody opens an account in Priscilla's branch. Let's say Shweta comes in Priscilla's as a client and connects through her mobile app to the server which Priscilla is running, and creates account X. So that database has to then be duplicated on the other servers also. So if you see other nodes also, because what if Shweta now goes back to Shashank the next day and now says I opened account in Priscilla's account. So everybody has to be in sync. So this is like a complicated problem. No, now earlier you were handling one client server. No, suddenly there are like two other server also. So as much as so in some branch, Borivali branch, let's say somebody comes and say I want to open an account. So will I be able to open an account if other servers are saying no, you cannot open this account, this person is having it's a wrong data, this person is we have done the validation. So everybody whoever does whatever action in the peer-to-peer architecture, everybody has to inform everybody else in the node that this is what I did with this particular transaction, this particular user, and you be in sync on that. Only then we will go ahead with your transaction, only then we will approve it, or only then we will allow something. So this kind of architecture becomes complex. Now what is the advantage of a peer-to-peer architecture? The peer-to-peer architecture is, let's say the Priscilla's branch comes down for some reason, Sashank's branch is still on. There is somebody in Priscilla's department, somebody is abusing the database. Shashank is there to verify whether that database is a correct database or not, because he has a copy of the database, he has a copy of the code. If any modification happens in Priscilla server, Shashank will know it. So so there is no single authority, and that is one of the things. There is no single authority in a peer-to-peer architecture. The authority is split across multiple servers. Now in Bitcoin or in Ethereum, these are all we say it is public blockchain. Now why it is public blockchain? Because these servers can be created by anybody in the public domain. So even tomorrow I can wake up and say I will be a node from Bitcoin. From tomorrow I will maintain the database of the Bitcoin. Now you definitely how many people are transacting in Bitcoin, how many people are sending Bitcoin and buying and selling Bitcoin. So it's a very big database in gigabytes and gigabytes. So initially when you want to restart initialize the Bitcoin server, it takes very long time, because you need to download that much of data. So to configure that kind of servers also takes time and it requires a good machine. But the idea is anybody can participate as a server. Anybody can connect to the server, any client. So usually client connects using a program called wallet. So wallet is like a Paytm wallet, and it is your any other wallet. But is the money inside your mobile? No, it is definitely on one of the servers. And whatever servers, if it is using peer-to-peer architecture, means your server, your database copy is also replicated on every other server. So now who is maintaining the servers? In case of Paytm, definitely these servers are maintained by Paytm. So which means it is a kind of a private blockchain. You can say if it is implementing blockchain data architecture, then it can be come across private blockchain. And so this is what is the difference between public blockchain and private blockchain. Now private blockchain is kind of controlled by a single authority, you can say, and public blockchain is like more of a controlled by the normal public domain. It is open for everybody to participate as a node or participate as a as a client and everything. Definitely everybody wants to be the client, but who runs the node means they have to sponsor, give their machines to be, for the purpose of running as a node. And every time the client, any client connects, now the client can choose, the wallet can connect to any of the nodes. It doesn't matter whether I go to Borivali branch or Palga branch, it doesn't matter. I can still transact any ATM I go, it still doesn't matter. It's still backend, the whatever the nearest server is, that server database will be updated, and that database changes will be pushed onto any other server. But definitely, in when we look at banks, they become like a private network. We, those servers is not something which we can touch. So Matoshi's idea was create a public bank. Let public manage it, take away the the control from the central, eliminate. So when what happens is, so Matoshi kept it very simple. We just want to know who sends the data to whom, and he is maintaining the simple database, and that is what his database is doing, maintaining a ledger. So if you are in the accounting world, a ledger is basically a set of transactions where you want to know how much was debited and who debited to what and what date it was debited. That's all that is there in a financial world. So and that database is as simple as that. Of course, you can then study more. So into like every block can contain 3 or 4 transactions, and and there can be many blocks, and one block and the blocks are in the order, like first this set of transactions happened in this block number 1, then block number 2 was created, and that block number 2 comes after block number 1. So it cannot happen that I had $100 and then I paid $10 and now suddenly my balance is $120. No, the transaction record has to have a sequence, and that is what is called a chain. The chain maintains the order of the blocks, and the blocks maintain the order of the transactions. So there is a term called Merkle tree. So Merkle tree is something kind of a data structure, you can say, but you study differently how this blockchain is stored using Merkle tree. Now Merkle tree, what is Merkle tree and how is it used to store blockchain data? So this is a kind of, we can take it as a homework. So when I say where it is. So now you know what is a block, right? A block is, Genesis block is basically the first record for this first transaction. A block contains a set of transactions, and the first first block that was created with a set of transactions, that is called the Genesis block. So who created the Genesis block for the question? Okay, well, who created the Genesis block for Bitcoin? Hello.
Yeah, is it? Hello.
Yeah.
Is it Satoshi Nakamoto?
Yes. So it's very obvious, right? The creator
Hmm.
create a Genesis block. So it's a creator. So creating cryptocurrency is nothing but saying, you're saying A is equal to 10,000, and you say this is 10. This 10,000 means 10,000 rupees, and you're giving it a name rupee. That is what currency is. Now, whether everybody believes you or not, it depends on whether the currency will be accepted or not. Tomorrow, somebody believes, okay, you're 10,000 rupees, so give me 10, give me 10, 70 rupees, I'll give you $1. And he'll so if they give you real fiat money, so fiat money is basically your like your paper money, so that is called fiat currency. So you can exchange your cryptocurrency with the fiat currency, but ultimately you just created a number. You can, so what did the creator do? He created some total number of bitcoins, or total number of he calls each number he identifies, or each value it identifies with a particular ID and something, and that ID becomes like your digital currency. And now anybody can take that ID and say, okay, this is ID number 1 is equal to 100 rupees note, and so ID number 1 is transferred to Priscilla's account. So it goes, so from Matoshi it went to Priscilla, from Priscilla it went to such thing. It is just like a ledger, so just so the read, if you do not understand your accounting world, read up what is a ledger. Okay, accounting ledger, how, what is debit, what is credit, So it is Bitcoin is nothing but a ledger. So that is a genesis block, and the first block that is created. So somewhere somebody has to start, no, with the first machine. Then how do you encourage everybody to participate in your currency? So if nobody, if Sashang was not ready to come up with a second server, this this blockchain would have been dead. No, only one server was there, only Matoshi was there. No, but Matoshi had a friend, and they promoted it, and then started transacting with each other, and then it grew, and then slowly and steadily he also disappeared, and nobody knows where he is, and now it has become like many other servers. So in Ethereum, I think there are around more than 11,000 nodes, which means 11,000 people in the world are managing this server. So the question is now, uh, what will happen if all the nodes are basically a machine, no, a server. So what will happen if all the nodes are switched off? Will the blockchain work? Not work? It is dead. What will happen?
It will collapse.
With
Yes, sir.
what will happen if I switch off all the nodes? It's like a laptop, no? I just switch it off. What happens to the programs on that? Will it run? Shweta, what will happen if all the nodes in a block, any blockchain is switched off?
So we cannot do the transaction. Record will remain in the blockchain, but we cannot do any transaction. Network will be inaccessible.
Yeah, basically it's disappeared, no? All your money is gone.
Yeah.
So
Yeah.
thing is, so definitely the blockchain can be destroyed only if all the nodes agree to switch themselves off. So remember
Yes.
this. But the thing is, the chances of this happening is very low because too much of money has gone inside the system now. There's a crores and crores of money. So tomorrow, let's say if let's say Sashank, you wanted to protect this, this currency. You wanted to make sure no nodes switch off or nothing like this happens. What will you do to safeguard yourself? You have invested 10 lakhs in this. So what will you do to safeguard yourself? Shweta, what will you do because you have invested 5 lakhs, let's say Shashank has invested 10 lakhs. Now you want to make sure this blockchain is alive. What will you do to safeguard? So Cecilia,
So can we do hashing in it so that it can be prevented?
um, who will do the hashing? Yeah, basically, see, let's say three of you are there, no? Shweta is there, Shashank is there, Priscilla. There are three nodes. Shweta,
Hmm.
and now you have not, sorry, you have not created a node so far. You have not actually, you are just a client actually. And you are
Hmm.
dependent on Shweta and Shashank. They are implemented a node through which you are transacting. They have the database, they have the server, everything is in their box. They have a duplicate copy, and they have both decided to switch off the machine. What will you do to make sure you lose that server or do not lose the data? What can you do?
So can we use the private keys?
No, that machine is switched off. No, once you switch off the machine, can you take out anything out of the machine? So basically what, let's say Shweta as a machine and Sashang is a machine. If I have invested, let's say, around 10 lakhs inside the thing, I will always be scared that there are only two nodes. Two nodes mean the chances of both of them switching off this machine, both of them know each other, then it's more problem for me then. So what will I do is I will create another node before they switch off.
Okay.
Node. How do we copy this? Sorry. I will take this node, whatever node this is, because what did I say? I told you that it is a public blockchain. Anybody can duplicate it. Is it right? Till then, to duplicate it, you just require one machine to be on. Correct? Are you all understanding what I'm saying? Are you all tired?
Sir, can you repeat the last two statements?
To duplicate, what do you require? A Xerox. In order to Xerox a particular paper, if the original paper should not be lost, what do? You take a Xerox. So you cannot take the Xerox after the original paper is lost. So before it is lost, you make a duplicate copy of that. So blockchain allows you to duplicate the entire server code and database. All the database can be here with you. So, so if,
Okay.
let's say Priscilla Shashank is switching off the nodes and Shweta is coming in as a client. Let's say Shweta has that database. So let's say
Okay.
to database, Priscilla decided to switch off a machine. From today onwards, I'm not going to support. Shashank said, I'm not going to be support. So what will happen after this? Blockchain will still be alive because people will start connecting to Shweta's box. All the client will come because there's only one box. So there's no other choice, no? Somebody will. So basically, that is called the node discovery. So you have to discover the node. Who are the nodes? So every time somebody new comes on the network, everybody is informed. When initially Priscilla was there, so only Priscilla was there. Then Shashank wanted to create a copy. He was told that every time anybody in the world wants to create a server, first they have to go to Priscilla's server, or they may go to some other server. There will always be that initial point where you have to connect to some server which will never be switched off. Ideally, will never be switched off if it is in the favor of whatever. But once even one person creates a server, I have the ability to connect to that server and duplicate it and become a live server. So peer-to-peer, a client-server architecture, if the server centralized architecture like a government implements a website, a web server, if that is switched off, then it is gone. But if I am implementing whatever the government is implementing on my server also, even if that machine is off, my machine is on, and people can connect to my server. It is the same duplicate copy. So I'm not working with the original copy, I'm working with the Xerox copy. But in the peer-to-peer, everything is an original. So okay, then everything, whoever changes whatever data, that has to be replicated on every other node, otherwise it will not be accepted. So that is what is that logic is called consensus algorithm. Everybody has to agree on the transaction. So this is again you can study what is a consensus algorithm. Consensus, the word means agreement. So so everybody where it is. What is a consensus algorithm? You can have a look at it. But so far, I have explained you a little difficult concept of peer-to-peer. So can you tell me if you understood or not understood? Why when the blockchain can be dead, and how can you make sure it is not dead? You always need one node. So did you understand?
Yes, sir.
Okay. So tomorrow I want to safeguard myself. What will I do then, Shashank?
You will make a copy of that node that currently
Is
uh,
alive.
alive. Yes,
Very
and
very good.
in the future, when that node dies, other people node will start connecting to your Xerox node.
No, that is people can connect to any live nodes
Okay, okay.
because in peer-to-peer, it doesn't matter which node.
Got it.
Yeah. So whichever
Mm-hmm.
you will give a certain money to Shweta. Let's say somebody is doing a transaction. Somebody sent 10 bitcoins. Priscilla sent 10 bitcoins to Shashank. 1 bitcoin Shweta will get because she is given a machine, no, to operate like a node. That is where the money is mining. That is processor called mining. So that is again for homework. What is mining? So mining is all about creating currency and managing transactions. So every time you take up any currency, cryptocurrency, it will always say we are going to mine 10,000 bitcoins, Yeah, we have mined 8,000 bitcoins. By the year 2024, we'll mine the rest of the bitcoins. You know, so every time one bitcoin is created, that is like a transaction. Okay, so it is like creating a new balance in your account. You know, you're saying I am putting 100 rupees. That is called mining. Then I take that 100 rupees. Out of that 100 rupees, I'm sending 10 rupees to Priscilla. That is a transaction number 2. That is called managing transaction. Then Priscilla takes a 10 rupees and says tells this is 10 bitcoins with me, Shweta. You give me 1 Ethereum in exchange of this. That is called crypto exchange. So that is another word. Are you all noting all this down? All this concept, otherwise we may be lost. Is it confusing?
Yes, sir.
Okay.
Crypto exchange is basically one crypto exchange for one cryptocurrency exchange for another currency. That other currency can be a fiat currency, or it can be a cryptocurrency. So my question: what is a fiat currency? I told you, what is fiat currency just some time back. Fiat currency is the currency created by the government. So, what are the examples of fiat currency? Which our government has which fiat currency?
Indian rupee.
Very good. So we have an Indian rupee. Now they're talking about a digital rupee, but digital rupee is a cryptocurrency. It has got no paper money. It is a digital money. It is on blockchain. They're creating that. But digital rupee is separate from rupee. Okay. Digital rupee will come in future. So that will be controlled by RBI, the central government. There will be no banks involved. And the value of the digital rupee will be same as rupee, but later on they may use some techniques to compete the digital rupee even with Bitcoin, and it can be more value. So digital rupee, though it has the same name as a fiat currency rupee, it is not the same technology. It may be of the same value, but it is not necessary it may have the same value, and it may get a different name also in future. We do not know. So Priscilla, what is another example of fiat currency? Give me some another example of fiat currency. Give me one fiat currency example and one cryptocurrency example.
So, US dollars, mm,
So
and another cryptocurrency can be Ethereum or Algorand.
yeah. So basically, Ethereum currencies are
Bitcoin.
called Ether. Okay, and there is
Ether. Okay.
7,000 currencies, cryptocurrencies in the world. So some of the famous currencies are Ether, ADA, and you can if you go into any of the crypto exchanges, you can have a look at them. Okay, so so now that you all have understood peer to peer, so peer to peer is nothing but an implementation of peer to peer is nothing but so I'll just write it down over here for your ease of purpose. Peer to peer is nothing but a collection of same and multiple client server application. So it is the same application because it's a duplicate copy, but it is in multiples. It is spread across on different peers. Peer is like a friend, nobody is a master. So usually a client server is called a master slave architecture, but peer to peer, nobody is a master. Everybody, all the servers are equal. Is this sentence clear? Peer to peer architecture is a collection of same and multiple client server application.
Yes.
Okay, so
Yes, sir.
any node you take, any peer you take in that network will have a server and will have a database, and which client connects to which server, it doesn't matter in the peer-to-peer architecture. The client can come in the form of a mobile app, can come in the form of a browser, and it can be anything, but nobody can say I added $100 and you don't, the other person says no, okay, you added, but it's okay, I'm not going to add it. Everybody has to, all the database has to be the same, otherwise that record is not allowed. That is what is called consensus algorithm. Okay. So as far as your so three-tier architecture, so I've covered all these terms: client server, three-tier, peer-to-peer, and what is block. As I told you, I mean, of course, you'll have to read up now a little deeper, how the block looks like, how the data looks like, and what is, look at the Genesis block created by Satoshi, whatever, Naka, I don't know. What is a node, now. So tell me, what is a node, Priscilla?
So it's basically like a connection where one part of connection has to be active so that the blockchain can work.
Yeah, it's basically any server in the blockchain network.
Yeah.
So server is just a machine, no, and the backend. So so it is any server in the blockchain. That is called a node. Okay. Sashang, what is a blockchain?
Yeah, blockchain are like a set of instructions, like uh, how to define in technical terms.
It's like a chain of,
Yeah, yeah, chain of block network. Yeah, block records.
yeah. Each block contains multiple
Hash.
transaction.
Yeah, 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 that also.
So what is a transaction then? Example.
Example like someone wants to send someone 2 or 3 bitcoins, then there must be a transaction ID and all those stuffs related to the transaction being done. So the block will store that
Yeah.
all
So one
those things.
transaction will contain from address,
Mm.
to address, date when it was sent, time when it was sent, and what else? And what else? In any transaction, what is the most important thing? Financial transaction.
Currency, how much amount and all.
Very good. The amount that you send. No, this is any लेन देन that you do in the world. किसने किसको दिया, कभी दिया, कितना दिया. This is a part of information which becomes your one transaction. So these two address is like basically this is called the your wallet address. So everybody who creates an account in in the blockchain, they get a wallet address. That wallet address is created using some encryption techniques, using something known as private keys and public keys. So you have to study now what is a public key, how what is a how what is a key, basically how it is used to encrypt data, how it is used to that's basically how keys are used. But keys are nothing but a complicated number, you can say, you know. So for example, when you have a lock and when you have a key, it has a particular combination, and some keys are more complicated and doesn't open in a normal way, so it's more difficult to duplicate that key. In the same way, private keys can be considered as a complex set of as a complex password, which is 256 bits. That is like it starts from 1 2 3 and then hash and this and that. Ideally, when we choose a password, it is like 16 character, 18 character. But think about, if a machine creates a password, how does it create those kind of passwords? Are used to open the file, close the file, open a transaction, view the transaction without the key, unless you give that password. So it is like a password. When you say private key and public key, the only difference is who has that password. Private key is a password which the client has. Public key is the password which the server has. Server has a common public key, to confirm the transaction. One, so basically you're going private key and public key, they work like your work like a bank locker. Whenever has anybody seen a bank locker, gone to the bank, and have you visited a bank locker? Anyone who has not seen the bank locker?
I haven't seen.
You haven't seen. Priscilla has seen bank locker.
No, sir.
Shweta. Okay. So it is like, think of a building with many doors. How many key is required to open one door?
One,
One key. Who has that?
One key.
the authority they are present there.
The owner, right?
Yeah, yeah.
The owner of the house will have the key. This is called a private key. Without the owner's key, the room will be open. But let us say this is a bank, so we want to open a big locker. So somebody says, I own this. This is my locker. So what will the bank do? That door will not open using one key. It will use two keys. You know. So and that key, who will have? Will the owner have or will the bank have? So basically, one door is opened using two keys. You can think of it like that. Every time you want to do and remove anything from the locker or open the door or close the door, you have to, the bank fellow has to come and use his key also to open the door. At the same time, you as owner, you also have to open the door. So private keys and public keys are basically not only used to open. It is like a password you can think of, but that password is used to lock the file, and so this kind of encryption techniques are used over here in blockchain. So private keys and public keys are like your encryption keys. Any question on this?
No, sir.
No, sir.
So that's why we say, from the wallet address, if you just say wallet address 5634, how do I know this is Priscilla? Is that blockchain storing Priscilla's address? Is blockchain storing Priscilla's any information, personal information? So Bitcoin, Satoshi, the way he did it, he said nobody knows anybody. Who's sending money to whom, nobody knows. All that he matters is sending the money. Why do you require banks in between to send for Priscilla to give money to Shashank? Why does Priscilla need James in between as a bank? Or why does Shweta needs Shweta has to be there in between the two in this transaction? Why there has to be a central authority? So all these problems are going away because of the peer-to-peer architecture. No single authority, many nodes. The public itself is owning the blockchain. So we don't need banks then. Whenever we use credit card, debit card, you are levied so many charges. It goes through so many machines, so many checks. We are always dependent on these servers. But now things are simpler. There's a simple way of doing things, and we are letting public do it. And when the public doing it, we are making sure they cannot tamper it, because even if it is a Xerox copy, nobody should print anything else on that. No, so that is where consensus algorithm comes in, to make sure everybody is in sync. So a wallet is like your private account ledger of the owner. So Priscilla has created one account. She will have her own wallet, and that wallet will have an address. If anybody wants to send money to Priscilla, they have to know the wallet address. That wallet address is nothing but it will be some kind of a private key or a public key. And using that keys, one can encrypt it. So anybody sending the money, it will be encrypted. So 10 rupees will not go as 10 rupees. So when the 10 rupees goes on the network, it will be seen as DEFG, and you will never understand what is that. Second time it goes, it will go as PQRS. So it is always encrypted. Unless you break the encryption logic, you cannot know what the data is. Until then, nobody is able to break the encryption logic. But if somebody has a key, private key, then they can open the lock. So always remember. So whatever that wallet is and whatever private key is associated with that, whatever password was given to you, if that password is got in somebody else's hands, that file is gone, and it is nothing but a file containing that password. If that file is got in hands of anybody else, he or she can transact with it. If you lose the file, if you forgot your password, you lost your wallet. Nobody can touch it, but you also cannot touch it. The money will lie there like an orphan. Is that clear?
Yes,
Yes,
sir.
sir.
Tell me,
Yes, sir.
Shweta, the difference between public blockchain and private blockchain.
Sir, private. Data, sir. Sir, public blockchain is like it is permissionless. Like we need not take anybody's permission, and it is non-restrictive. So and it is distributed. Like anyone can be connected to the internet.
Anybody can become the node.
Yeah, anybody can become the node.
Yeah, see,
And
in the application, you can either have a wallet. I'm a Paytm client, so I'll just have a wallet. I may not be a Paytm server, but if Paytm server is implemented using public blockchain, then I can become the Paytm server. I can become the node itself. I can store all Paytm transactions with me. So that is what. So in a public blockchain is where the blockchain is managed by the public.
private blockchain, it is permission oriented, means it's a restrictive blockchain. So it can operate in closed network, means within the organization where only particular members will be involved.
Right. So whenever, let's say now the government has announced that they are going to come out with a cryptocurrency called it is going to be called digital rupee. It is going to be a private blockchain. Who is going to run it? RBI is going to run it. And who later on in phase two, what government RBI may say, okay, let banks also operate digital rupee. So I am going to allow only banks to be the nodes. I will not allow the normal public to be the nodes. So this it could be an example of a private blockchain where a certain set of authorities are coming together, or maybe only single authorities coming together to control it. So Binance, if you look at Binance is an example of a private blockchain. So you have to know the difference. The private blockchain, you can control a lot of things, you can modify a lot of things, but in public, and you are dependent on on the private authority. And but in public blockchain, everybody can access it, but you cannot modify so easily. Then private blockchain, if it is in my authority, then I can modify the code, or maybe I can do something. But in public blockchain, you cannot modify the code, because the moment you modify the code, one place it will a plus b may become 3, other place suddenly if you modify the code it may become a plus b equal to 4, and that can never happen. So in that case, the you cannot modify once a currency's code, the code driving the currency is fixed. It is fixed. You want to now modify the code, you have to create a new currency. Take the old code, add new code into it, and name it differently. It is like I am having a Coca-Cola bottle. Now I want an orange also in that. I cannot do that. If I want a drink with Coca-Cola plus orange, then I take Coca-Cola, then add orange and give it a different name. It is not Coca-Cola then. It is Coke Orange or something. A different currency name. You can copy it, but it cannot be the same name. Or I can take Coca-Cola bottle, take the Coke out of it, and call it uh, um, Resila drink. The drink is the same, the name is different. So you can even copy the code and give it a different name. Is this part understood? You can create your own currency with the same name and create your own Genesis block. So nobody is stopping you from creating your own Genesis block. You can say how many coins are going to be there. That is how cryptocurrencies are created. So when I'm going to have a class, probably means I will see what I can teach you here, but definitely in Solidity class you will be learn to create your own cryptocurrency kind of stuff, or own node, be that initial node, create your own Genesis block and see all the transactions. So all those little things you can you can go through your in Solidity. So Solidity is a language used to write smart contracts actually, but there are using some tools, some other we're not talking about Solidity, but also there are other tools also in the blockchain to create a node, and some other technologies that can be used to create a node. And Solidity specifically is used for smart contracts. What is a consortium node? Consortium blockchain is where there is not one authority, but there are multiple authorities, but it's still private. So for example, all over the world, all the governments comes together. So US says I have my US data, India says I have my India data, and then Africa says I have my Africa data. Now they want to, they are all operating on similar kind of data, maybe citizens data, maybe the health data. So what they can do is probably they can become a group of private blockchains. So but they are all focusing on one problem, or set of problems. All are trying to say we'll create one world, one world government, and we will get our private blockchains together, and we will operate. So just like digital rupees, there may be a digital dollar on the other side, and the government of US will say, okay, we'll transact with you with a digital rupee, but it will be through the private blockchains belonging to the governments. So consortium blockchain can be thought of as a group of private blockchains. Is this understood?
So
Yes,
it's
sir.
like decentralization.
इसमें sorry क्या?
So this is consortium blockchain. So is it like based on decentralization?
Yeah, means it is still a decentralization, but it is still controlled by the private. If the private, like the private creator of the blockchain, says there has to be no nodes, then it will never happen. If let's say digital rupee in a government is starting, RBI is going to control it. No banks are allowed so far. It is going to be only the servers which the government allows, RBI allows. But tomorrow it is quite possible that RBI, the central bank authority, says, I want local banks also to do allow digital rupee transaction. So from now on, the only cryptocurrency that will operate is digital rupee. So it lets those private banks access the server and the node, and so I forgot what is the point is, that is a private blockchain. But on the US side, it is quite possible US has created a similar cryptocurrency, and it is calling it is a digital dollar, and it is also allowed its own banks, but those banks are different, and our banks is different. On their side there is Bank of America, on our side there is Bank of India, on our side there is RBI, there is a federal bank, you know. Now federal bank and RBI bank comes together and say, they both of them join hands together. They, one person says I have मेरा खुद का blockchain है, another person says मेरा भी खुद का blockchain है. चलो हम लोग एक दूसरे से मिलके एक कंसोर्टियम ब्लॉकचेन बनाते हैं, और सबको विल अलाउ एवरीबॉडी टू ट्रांजैक्ट ऑन इट. So anybody wants to transact using dollar and dollar and digital rupee, they can transact it. So that is called consortium blockchain. Consortium blockchain makes sense when there is a common purpose, कि हम दोनों साथ में मिलके पार्टनरशिप करेंगे ऐसे. So it is still like multiple private blockchains.
Okay.
Okay, so we will study a little bit more, when we are doing the course, and for me also this is a new thing, and even I am trying to understand. For me it is the first time I am coming across this consortium blockchain. I didn't even know there is a public blockchain and private blockchain also. But and I'm looking into a lot of aspects, like where is the data stored, how do we have an optimized way of managing data, because a blockchain contains a lot of data, no, in there's so many transactions in the world. Think about it, there can be gigabytes and gigabytes. Now every node has got that data, means there's too much of duplication of the data and too much of management. So how do you manage that? It is a lot of electricity goes through it, and what kind of computers are needed. So those are more technical questions, but that is there on my mind also. And but at a very high level, I hope you all have understood what is a public is managed by the public blockchain, private is managed by the private blockchain, and consortium is managed by the group of private blockchains. So what is a smart contract? Anyone?
Sir, I think it is the set of programs that we write for the blockchain network to successfully establish or transact or make it feasible.
Yes, in a way it is, you can say it is a set of programs, yes. And anyone, any idea what you all understand smart contracts? Shweta, any idea?
So is it a code to set some rules?
Very good. Set of rules. So it's still a program, but the program will implement certain rules. What can that rule be? That rule will control the transaction. It will say when the transaction can happen. For example, you are selling a car. Will anybody give you the car without a set of documents, without a set of stamp duty, whatever that registration is, without any license? Every domain has a process involved in it. In the real world, money is not only exchanged, it is services which is exchanged for the money. Is this part clear? But how do you know whether the service is given or not given? When the service started or when the service ended? That is where all the rules, all the processes, I told you about process and data, that is implemented in smart contract. So when you say you can write a smart contract, Solidity is one way of writing it. You can define your rules, you can define your function calls, you can define your data, and these smart contracts, are you can also send money and receive money through the function calls inside a smart contract. That if this happened, it is like a simple logic program. Any program that you have, your Python program, you say no, if a is equal to b, then save the data. So that is like a one simple rule. So that is how contracts are written. The only thing is the syntax we have to learn how it is implemented, and that smart contracts is works in tandem with the blockchain. So smart contracts is a piece attached with the transactions. So transactions won't happen without a smart contract. So what happened is initially when Satoshi created Bitcoin, he only recorded what is a transaction. There was no way, there was no smart contracts. There was no way to define a rule. Anybody can send money to anybody. But now businesses wanted to use blockchain. They want to implement program, and Satoshi has said you cannot touch my code. This is a transactional code. So what do? That's where Ethereum came into picture. Why Ethereum implemented? They say, "अरे ठीक है, in the real world this is not practical. Only transactions do not work. No, पैसा सिर्फ देके हमको कुछ मिलना भी तो चाहिए, मतलब कुछ product or something, and then I'll get that product based on some documentation. So how do you manage that? So this is like adding your program logic or your rules, and your data, you know. So smart contract is like your extension of your any transaction. So every transaction may be attached to a smart contract or may not be attached to the smart contract. But any businesses in the world these days, and that's why Ethereum became famous, because it was innovative. They offered something different. They offered something which was real. Let's say so now every industry is trying to, now once you define this, your smart contract does not necessarily has to be money oriented. Maybe I'm just exchanging documents and there is zero transaction happening with that. So this smart contract, I may just exchange the document verification, so and that transaction value will be $0. But there may be actually a payment. Once this rule number 1 is passed, I do a payment, and in this in this particular process, $100 was given.
Excuse me, sir.
Yes.
Sorry to interrupt. Like I have some important webinar coming right now at 5:45.
Okay. What is it?
Can I leave? Right now it's 5:42.
ठीक है. We are almost done, so you can leave. And we'll meet. I'll let you know. Shweta also will be coordinating for us. We'll get in touch.
Okay, sir. Okay, sure. Do let me know if I have some work
So
to
I'll
do.
upload this video. And
Okay, sir.
because it
Okay.
seems like if I'm having something more, then I'll upload the video. Okay.
Okay, thank you, sir. Okay.
Okay. So Priscilla and Shweta, you all have understood the difference between Bitcoin and Ethereum. Tell me, what is the difference between Bitcoin and Ethereum? Both are implementing cryptocurrency. What is that one difference between Bitcoin and Ethereum? Everything is like same, like transaction is same, consensus algorithm is same. It's a peer-to-peer network. Everything is same. What is that difference? One difference between Bitcoin and Ethereum. Can you do business on, can you exchange services on Bitcoin? How are services implemented in, hello, hello there?
Yes, sir.
The difference is smart contract, no? Bitcoin manages,
Yes, in Bitcoin there is no smart contract, and in Ethereum is there is a smart contract like in MetaMask and all.
Ethereum as is not only it manages transaction, but to manage a transaction it also gives you a way to define your smart contract. Define and manage your smart contract. So this smart contract can be coded depending on what service you're looking at. If you're looking at a sale of a car, then that smart contract will be different. If you're looking at Aadhaar card verification, that smart contract will be different. So smart contract is just like your program. So the difference between Bitcoin and Ethereum is Bitcoin is a both of them use blockchain, both of them use peer to peer, but Bitcoin does not know what is this transaction for exactly. Ethereum, like they can, you cannot do any other thing. You can just send and receive money over here in this. Either you send or receive money. It is just like your simple bank. Ethereum not only lets you work like a bank, but it also lets you work like a business. Any service will be based on some agreement, no? Any service that you get in the world, internet service, there always be an agreement. If you give me these documents, then it is I will give you. Okay, now if you want this service and you are agreeing, then you send the money. So sending and receiving money is after the agreement has passed. So how do you implement that agreement? Using smart contract. So every business wants to implement have its own smart contract. Is this clear?
Yes, sir. I had a question, sir. Sir, regarding smart contract which you were saying, so is it only used for one transaction or for multiple, sir? Or we
For
have to use
every
different?
transaction, the smart contract is common. You can define,
Okay.
you can say every transaction is bound by two contracts, or and you can also say every one smart contract is requires permission from three different parties. You can
Okay.
define complexity in the smart contract.
Okay, sir.
In the real world, that is how it happens. You have a document. The document may be involved. They'll say bank se permission lo, government se permission lo, mata pita se permission lo. That is like
Mm-hmm.
one contract. Your one admission is depending on three different approvals. So that is what the contract is. Now one admission is equal to one transaction. So the same agreement has to be applied for the second admission also. Those contracts are same. Maybe there are multiple contracts to be signed. That is possible. But what if there are multiple contracts to be applied for one transaction? It has to be applied on the other transaction also. It cannot be different. Agreement is
Okay, sir.
the same. If you want a
Hmm.
school admission, you will have a set of processes. Whatever processes were applied on one admission has to be applied on the other process. If there was an interview over here in the first admission, then the interview will be there in the second also. So the smart contract will become common for that particular application. So I'll just say, are you all getting a little bit idea? At least I'm going to talk a little more now. But are you getting an idea?
Yes, sir.
So let's say A wants to give money to B. So this is a transaction. Now in this transaction, I can create an application which which has a smart contract defined. One, to give admission. So this is application. So this is a application created for education. I can have application number 2, which is health. In this, the set of processes are different, so the contract is definitely going to be different. The set of data, the set of functionalities. So this is some other contract release. Contract number 2 to admit patients. So this kind of application which uses your blockchain transaction. It is called, you can say, DeFi dApps. dApps are nothing but your decentralized apps. So decentralized is a term that we use to, which is opposite of centralization. And decentralization also means peer-to-peer. So now the thing is, even though there are two different applications, they're using the same network, because underlying money is common for all. No, whether you go to give admission, once the admission contract is signed, you signed all the papers, you still give the same rupee. If somebody else is getting admitted in the hospital, the process may be different, the smart contract may be different, but once a contract is done, that person can be admitted using the same rupee. So the currency, the underlying transactions, the blockchain data is same, but contracts can be different for every transaction. Did you get this?
Yes, sir.
Yeah. So contracts. Now, does the when you give money, take money, does it matter to which, does it matter to this blockchain network? What application is using this?
No.
Yeah. So the blockchain's main duty is to just maintain transactions. It is not to maintain smart contracts. It's a facility. Ethereum has designed the architecture in such a way that you can create smart contract for your application, and you can bind your transaction to your smart contract. So the question is, how do you do this? So that is where Solidity is used. That is where in this particular challenge we are using substrate. That is where substrate will be used to create smart contracts. So the question is, this is a very important skill. Tomorrow some business is there, they say the money has to be sent based on so and so rule, so write a program. So what language you want to use? You may use Solidity, you may use substrate. No, so those kind of things. So this skill, if you know Solidity, they say you know Solidity, which means you're telling to create a smart contract and bind your transaction to the smart contract. They will tell you in a smart contract what should happen, what data should be there, what data should be verified, so everything they'll give you like a requirement. But ultimately, you should be able to write a program using like in the smart contract fashion. Smart contracts are specific programs for supporting the blockchain network, blockchain transaction. So every transaction may be connected to different smart contracts. Every transaction, so just you may want to note this down. Every transaction may be bound to a different smart contract, which means one transaction may be bound to one smart contract, just like the above example, and the second transaction may be bound to some other smart contract. It depends on which application it is. So smart contracts are very specific to applications. And at the same time, I can also write every transaction may be bound to one or more smart contracts, which means verification process. I may just have written, there may be two businesses, and one business has one smart contract, other business has second second smart contract. And whenever I as a client want to get a particular service, I need a permission from both the parties, both the businesses, in which case I'll have to make sure their smart contract also is agreed on, and second party's smart contract is also agreed on, and then only the transaction will be done. That is how the real world works. Real world does not work with one person, one company, or why not? It is always suppliers are there, and retailers are there, brokers are there. It's a set of people all come together. Doctors are there, patients are there, workers are there, and trustees are there, governments are there. It never works, and that's why blockchain comes with the power that data is shared with everyone. Anyone can participate. So whenever you don't want to have a ability to control the entire data, and you want to make sure it is a free flowing system where anybody can come in and check the data and everything, blockchain is used. So but blockchain is expensive because it's not very easy. It is not very, there are too many servers involved, and to duplicate the data is very it can be take a lot of space. It may involve cost, and so it is a complicated complex architecture. When you compare a centralized architecture like client server architecture, it is more of a peer-to-peer architecture, and more the number of nodes, more difficult it is to kill the blockchain network. So any questions on this?
No, sir.
No, sir.
Yeah, so just you can take it as your homework, to read up, because these words will come up in your interviews also, and all these things, questions will come up. And the more you read up about it and understand it from your perspective, okay, this is what I understood, okay, try to be more, just don't forget it, and then, you'll forget again then. So that's why it's better that you, once you get out of this class, you can always just see some other video, understand their perspective. Maybe they have a different way of explaining things.
Okay.
But ultimately, we have to understand it is all about data, process, and user interface. That is all that it is. So, only difference in a blockchain is there is a peer-to-peer architecture in which every peer node has a same client server application. So, the question was now, what is the time? 6 o'clock. The thing is, we have to give an idea to the competition purpose. So let me at least stop the video.